It is freaking freezing out there. And I think it might be all our fault. That's right, the very podcast you're listening to right now may be responsible for the polar vortex shifting west to Alberta. Why? Well, because the exact week I scheduled to do a podcast episode about using the Earth's heat to power your house, heat a barn, or keep your greenhouse going is the week the temperature dropped about 1 million degrees. Coincidence? I think not. But it's not going to stop us from doing this episode. I'm Derek Leahy, and in this episode of Rural Routes to Climate Solutions, we're going to talk about geothermal energy and agriculture. My guest today is Dr. Jonathan Banks, who's a research associate at the University of Alberta. He's also a member of the university's geothermics research group. Now, originally you're from the U.S. How'd you wind up in Alberta?
Oh, it's been a long road from here back to where I came from in the U.S. I was originally born in Boston. I've lived in many different places in the U.S., but I came here most immediately from Germany, where I did my PhD. I was recruited for a postdoctoral fellow's position here in 2013. The person that recruited me abandoned their position shortly thereafter, and since then I've been sort of the focal point of geothermal energy research at the University of Alberta, which started out with just me and my boss, my new boss. And now we've grown into a fairly large research program that has close to 10 faculty members and 40 graduate students and postdocs spread out across 4 or 5 different faculties on campus.
Oh, well, yeah. Check out your guys' website and looking at your bio. And I think we might have been in Germany the exact same time. I was in Berlin from 2006 to 2011. Where were you?
Wow. Okay. Yeah. I lived in Berlin from in 2003 and 2004, and then also from 2009 until 2013 when I was doing my PhD.
Oh, okay. First question. What is geothermal and how does it differ from Geo Exchange?
Well, geothermal broadly refers to the heat of the Earth. So the reigning theory is that the Earth formed in the distant past when a whole lot of space material slammed together. This generates a lot of heat, and the Earth is actually still cooling down from that. So the Earth's interior is hot. And it's a little bit different when you get closer to the surface of the Earth where the heat comes from. But the Earth is hot, and the deeper you drill down into the Earth, the hotter it gets. So that's what geothermal energy is somehow using that thermal energy content, that heat of the Earth, for either directly as heat. You know, it's very cold out today. We could use some heat, or to convert the heat if it's hot enough into electricity. So that's what geothermal energy is, how it's produced, and the specific technology involved and the specific end uses involved. That starts to get into the distinction between ground-sourced heat pumps and commercial geothermal energy.
Okay, so when we talk about ground-source heat pumps, that would be Geo Exchange.
That's right. Yeah, sorry. Okay. Yeah, so Geo Exchange, the exchange there is basically you're using the very upper surface of the Earth, so less than 100 meters typically, as a thermal mass.
Oh, okay.
And in the summertime when it's hot, you can use a heat pump to. So heat, as a thermodynamic principle, heat flows naturally from hot to cold. Okay. If you have a heat pump, you can reverse that flow. And so in the summertime when it's hot, you can pump that heat into the ground where it'll store it. And then you can release it back into a building or, whatever you need your heat for in the wintertime. And that's Geo Exchange.
Like a lot of farms, just like everywhere, they have cellars for like storing like root vegetables and stuff like that. Is that Geo Exchange? Like in that case, it's cooling those, or is that something entirely different?
That is an excellent example of traditional uses of geothermal energy that doesn't involve modern industrial technology.
Okay,
yeah, but that's exactly what that does. A root cellar is typically keeping stuff cool and dry.
Mm-hmm.
Yeah.
Okay. Yeah,
And they're typically in a cellar because they're using that thermal mass of the Earth to maintain a constant temperature.
Right. Okay. So then, in some ways, it's actually not that new. That's something that humanity has been doing for quite a while in that particular form. Yeah.
Not new at all. Yeah. Definitely, there are ways to optimize that, and especially if people are looking at building new infrastructure, there are ways to really design for that using modern technology that will improve, how well a traditional root cellar would work.
Okay, cool.
Yeah.
Now, this question is going to make me sound a little stupid, I think, but one thing I don't get about geothermal is how we're not like draining the heat from the core of the Earth out. Okay, I'll give you this analogy. So I have a helium balloon, I put a pinhole in it, and obviously all the gas comes out and the balloon deflates. So if we're drilling holes in the Earth, we're not going to deflate the Earth, but how is all that heat not escaping and causing cataclysmic problems?
Yeah, so that is a good question. The Earth is huge and contains enormous amounts of heat. Okay. So just a couple of statistics here. 99% of the Earth is over 1,000 degrees Celsius. And we're talking about the volume of the Earth here. So huge, basically an infinite reservoir of heat in the mantle and the core. The surface of the outer core of the Earth is hotter than the surface of the sun. And so it's not like a helium balloon where that leak is slowly going to drain all your heat out. At the surface of the Earth, and here's also directly addressing your point, what we're able to access of the Earth's volume is vanishingly small. Rarely do we drill a well that's 10 kilometers deep. The deepest wells are not much more than that. In Alberta here, typically our wells are 3 or 4 kilometers deep, 2 to 4 kilometers deep, whereas the core of the Earth is thousands of kilometers. So we're not even poking through the surface of the balloon to get the heat.
All right.
So
that makes a bit more sense.
There's so much of it. And in fact, the Earth is cooling, which means more heat is lost into space every year than is coming in from the sun, just to put the scope of how much heat is leaving the surface of the planet every year.
Okay.
Yeah.
All right.
Let me just qualify that statement. When I say the Earth is cooling,
go for it.
That is not a comment on climate. That's a comment on the temperature of the core and the mantle of the Earth.
Okay, my next question is going to be, are you a climate change denier? But I can skip that one.
Just want to be clear. I know sometimes words can be taken out of context.
Fair enough. Now, as for geothermal, I'm assuming you can't just find it anywhere. Typically, where can you find good sources of geothermal energy?
Yeah, so typically the good sources of geothermal energy are the areas where that heat is escaping out into space. And so the Earth is like the Earth itself is like a giant rolling, boiling pot. If you boil water in a pot, you see that bubbles start to form on the bottom of the pot. And then as it gets hotter and hotter, those bubbles start to rise up. Then you get a rolling boil. This is called a convection current. And so what happens is the water at the bottom of the pot heats up faster. It becomes more buoyant than the water at the top of the pot. So it rises up. And then when it gets to the top, it releases all of its heat. Now it's cooler, becomes less buoyant. It sinks down to the bottom of the pot. And so the water physically is rolling through the pot in a rolling boil. The Earth actually works in a very similar way, but with molten rocks that go through this rolling boil on the scale of hundreds of millions of years. And the places where the top of the roll of the boil, we have what are called spreading centers or mid-ocean ridges, where the Earth's crust is spreading apart and new crust is being created. A lot of heat is being given off in those areas. Tremendous amounts of heat escaping at the Earth's surface in those areas. The other side, once that cools on the down part of the roll, that's where we get subduction zones, which are the typical classic, Cascadian volcanoes. So Vancouver Island is kind of sliding into the west coast of North America. There's an oceanic plate that's kind of subducting down underneath British Columbia, Washington, Oregon, down through California. So you get these chains of volcanoes, Mount Rainier, the Garibaldi Belt, Mount Baker, etc. And so also a lot of heat under those things. Or you have an area like, for example, a major mountain building zone like the Himalayas. So the heat flow on the south side of the Himalayas, where India is still crashing into Asia. Tremendous amounts of heat flow there. And so this is where historically geothermal energy has been developed, because it's really right at the surface. You can see it. It's boiling. There are hot springs. There's a geyser. There's a volcano. These places tend to be geographically isolated. The mid-ocean ridges, for example, are in the middle of the ocean. So not taking too much advantage of
that would be difficult, yeah.
Hence the name mid-ocean ridge. Scientists are good at naming things sometimes. So recent advances have started to look into sedimentary basins, which is what we have here in Alberta. And so that's taking advantage of a more average geothermal gradients. In Iceland, you can drill a few hundred meters and get a lot of boiling water. Normally, you need to drill about 1 kilometer to increase the temperature 30 degrees. That's the average continental geothermal gradient, is 30 degrees per kilometer.
Okay.
And so in Alberta, we are over a great big basin, which means that we can drill deeply into the basin before we hit crystalline rock.
Okay.
And so in Western Alberta, especially, we can drill 4 or 5 kilometers, which means nominally we could expect to get water that's above 100 degrees Celsius, in some cases well above 100 degrees Celsius. And theoretically, you can use that to make electrical power.
Okay. And in that case, like the higher the temperature, the more power, like more bang for your buck kind of thing?
Absolutely. Okay. Yeah. So that now addresses the other side of the Geo Exchange versus geothermal energy scenario. Leaving the Geo Exchange aside and talking about the geothermal scenario, now we're talking about actually circulating fluid through the deep earth, not just using the earth as a thermal insulator, but circulating some kind of fluid. And yeah, as far as electrical power production is concerned, the higher the temperature, the more electricity you can produce. However, in Alberta, we have an interesting case because all power is created by a temperature differential in a turbine. A coal plant is boiling water to produce steam to drive a turbine. And the hotter they can make that steam, the faster they can turn that turbine. So the geothermal plant works in a very similar fashion. Some of them do run on steam. Others, especially at the lower temperature side, run on what are called organic Rankine cycle engines, which is where you're boiling something that is a lower boiling point than water.
Okay.
So instead of boiling water, which boils at 100 degrees, you boil an alcohol or a refrigerant or an organic solvent that boils at 50 or 60 degrees. So you can boil more of it at a lower temperature.
Okay.
But this principle remains: you need to boil something, so you need a temperature gradient. In Alberta, we have a low side. So we can't get the very high temperatures that we find in other places, but because it's so cold here, we're able to take advantage of the temperatures that we do have for making electricity, but we also have an elevated need for just the heat.
Okay.
Yeah. And in fact, some of our research has shown that the value of the heat, both in an economic sense and in the sense of reducing Alberta's greenhouse gas emissions, is about 10 times that of the value of electricity.
That's actually one thing I did want to ask. Like, are there any greenhouse gas emissions associated with geothermal energy?
There are greenhouse gas emissions associated with the construction of geothermal power plants. So in the steel casing that goes in the wells, in the manufacture of the pump, and the rigs getting out there and drilling. So there are greenhouse gas emissions associated with that. In some geothermal systems, there are gas emissions as part of the geothermal flow. So for example, in the power plant that I was working at in Germany, in Groß-Schönebeck, they had about 15% gas flow in their, on average, fluctuated quite a bit, but on average they had about 15% gas flow in their total geothermal production. Of that 15%, something like above 90% of it was nitrogen, which is basically what we're breathing. So some gas emissions, and we're not talking about like NOxes and SOxes, that type of nitrogen. Other geothermal systems, and this is something that we do expect to find in Alberta, there may be some toxic gases in the geothermal flow. Hydrogen sulfide is always a concern here, which can form gases. There may be some carbon dioxide that exsolves out of the geothermal brine flows here in Alberta. But if you look at it as if you look at the overall embedded carbon and emissions footprint in a geothermal system, it's lower even than some solar systems, which there's quite some toxicity involved in the production of the materials and the storage facilities and whatnot. So it's a misnomer to call it carbon-free. It's a misnomer to call any electricity conversion power that we have on the planet carbon-free.
Very true.
But it's very low carbon, is what we call it.
Good to hear.
Yeah.
And the water that cycles through is like, we have issues with tailings, obviously, when it comes to mining and oil and gas. Do you need tailings ponds for something like this?
Mineral precipitation from geothermal brine and managing as is often aggressive geochemistry of geothermal fluids is a problem in the geothermal industry. In some cases, tailing pond type ponds are used, for example, to manage the precipitation of silica.
Okay.
Far less toxic than a oil sands tailing ponds, with a different level of toxicity, different scope as far as spatial dimensions are concerned. So tailings ponds are one way that scaling is managed in geothermal systems. In the types of geothermal systems that we have here in Alberta, more common would be to put like dishwater softener in the re-injected brine. So we have, the problems arise with like calcite scaling. So the type of stuff you'd expect to find on your boiler at home. So we can manage that with filtration. We can manage that through acidifying, putting a dilute hydrochloric acid into the flow stream, which also is a way to treat the reservoir, open up some flow space in the reservoir. We can treat that with Calgon, is what they use in some German geothermal plants. Calgon is literally a dishwater softener. They will go to Costco, Metro, the German version of Costco, and buy a boatload of dishwater washing machine softener, and they'll dump it into the geothermal flow stream.
Okay, I guess. So something that can, I don't know, easily is the right word to use, but it's something that can be mitigated at least.
It's a case-by-case basis. So the flip side of the equation, the Groß-Schönebeck power plant, and those guys might get mad at me for saying this, but they're already kind of mad at me because I've said it so many times. They had their water, just put quotation marks around water for those listening at home. Their water looked more like the Starbucks coffee than it looked like water when it came out of the ground. It was, it had nearly 10 times the salinity of seawater. It had very aggressive heavy metals in it, cadmium, arsenic, lead, these types of things. I did my PhD on studying barite precipitation. Barite is a barium sulfate. It's a salt. A lot of industrial value in barite. We did look at, can we recover some of this barite for industrial value? It's used in paint. It's used in cosmetics. It's used in drywall. Many industrial uses. What was happening in this particular system at Groß-Schönebeck was that when the barium precipitated, it would incorporate whatever radium was in the water into the barite crystal structure. So we had barrels of radioactive barite sitting in the back of the plants. And this mineral precipitation, because they did not plan for it in advance when they were building the power plant, it basically killed their whole project. They couldn't get water circulating through the wells because after a short amount of production, they would have 100 or more meter long pile of mineral precipitants that had formed at the bottom of the well.
Wow.
Yeah. So
room for improvement?
Room for improvement.
Okay.
They're still trying to figure out what to do with that. It was a pretty big investment on the part of the German government and the European Union as well.
Okay.
So good luck to them. I've moved on. I doubt they're listening.
Well, hopefully that doesn't happen here when we start developing geothermal.
We have a lot more experience here with these things than those guys did. Not because we here at the university do, but because our oil and gas industry are world leaders in many, many of the things related to geothermal energy. So, which is one of the reasons why this is such a, pardon the pun, hot topic here in Alberta, is that geothermal energy is a renewable resource that takes advantage of our bread and butter here in Alberta rather than kind of pushing it aside or trying to move on from it prematurely.
Okay. Well, speaking of hot topics, what are some of the hot spots for geothermal in Alberta?
So there are two ways to look at that. One is, where are the hottest temperatures? And then the other way to look at that are where does the temperature increase the fastest? So if the geothermal gradient is higher in an area, it means you need to drill not as far to reach the same temperature as you would in an area where the geothermal gradient is lower. So the hottest temperatures, it's basically the further west you go, the hotter it gets because you can drill deeper into the basin. So out by Hinton, Grant Cache, these areas, even up by Grand Prairie, definitely get well above 100 degrees. We've seen some wells out by Hinton that are over 180 degrees.
Oh, wow.
Very deep wells, over 5,000 meter deep gas wells. So we know the temperatures are there. What starts to become less known in those really deep parts is how wet are the reservoirs and can water flow through them.
Mm.
We just did a project in Hinton where we were looking at some mid-depth wells around 3,000 meters, gas wells, and the temperatures were there. They were around 120 to 140 degrees, but we couldn't get any water to move through them.
Okay.
For a variety of reasons. So that's one consideration. So that's the short answer is the further west you go, the hotter it gets. In the area between Edmonton and Red Deer, even a little further south than Red Deer, down to Rocky Mountain House. I guess Rocky Mountain House is west of Red Deer. But there's a thermal anomaly in the basin that basically extends from the southwest corner of Edmonton or out by Devon down to Caroline, let's say.
Okay.
And west out to, I don't know how to say this word, but Wabbamum.
I have no idea.
I don't know.
It's a very good attempt.
I'm sorry, Albertans. I love you guys. I'm going to say Wabbamum, where the big coal plants are. So there's a big thermal anomaly in that area where the geothermal gradient is elevated. So in some cases, over 40 degrees, approaching 50 degrees Celsius, which means if you drill 2 kilometers, you can get a solid source of heat there, especially if you're not talking about electricity, but you want to use heat for an agricultural purpose. 2 kilometers is not a terribly deep well in Alberta. Yeah.
Okay.
Yeah. And there's a lot and we know the geology of these areas well. Like if you say we're looking for an aquifer at this depth, chances are we can find one.
Okay, we know the geology so well just because of all the oil and gas activity that's taken place over the years.
That's right.
Okay.
Yeah.
And as far as I understood, and correct me if I'm wrong, there's 2 applications with geothermal. So you have heating, you have electricity, and you kind of touched on how these processes work. But just one more time, like how exactly does the electricity process work, and how exactly does the heating process work?
Okay, so in an electricity process here, with the temperatures that we have, we use what's called an organic rankine cycle engine. There's another type, or a binary. The general term is a binary power plant. Rankine was a guy who made this particular type of invention. And what happens is hot water is produced from the subsurface. The heat in it is transferred into a working fluid through a heat exchanger. As the working fluid boils, that drives a turbine just like any other, fossil fuel or nuclear power plant. They're boiling water. The boiling process turns a turbine. The turbine produces electricity, gets sent to the grid. In this case, it's just the fluid that's boiling is not water. It's a fluid that boils at a lower temperature than water. And then the cooled geothermal brine is reinjected into the reservoir to maintain circulation. And it's injected in such a way that by the time it gets back to the production well, it heated back up. And so you can get these self-sustaining systems that can last 50 or 75 years. The technology in the wells and in the pumping will become obsolete before the reservoir runs out of heat by a long shot.
Okay.
If done properly. Heating is basically the same. And to do that with electricity, let me just add, you really do need, right now in Alberta, we really look for resources above 100 degrees Celsius. 120 degrees would be better. Mm-hmm. But we think we can do it with 100 because it's fucking cold out there. Sorry.
I don't know.
Not to put too far. I don't know how the farmers here are talking. I don't know how else to describe it. With heating, it's the same thing, except you remove the generator, you remove the turbine from the equation. You just have the heat. You produce the geothermal fluid. There's a heat exchanger where the heat from the geothermal fluid is put into a clean fluid. This can be water if you want it to be a propylene glycol, an antifreeze type solution, probably better given that it's fucking cold out there. So yeah, propylene glycol is commonly used. And then that is transported through a heating network in whatever you want to heat. So roads, is one that we're starting to look at more seriously due to the high economic and environmental costs of keeping snow off the roads. Greenhouses is everybody's favorite thing to heat with geothermal power. And this is something that is really a growing industry Thank you.
Well done.
In Europe, this use of geothermal power is really taking off, and you don't need a high temperature source to do this. For example, in Scotland, they're looking at fueling greenhouses with heat off of abandoned coal mines where the temperature is really not much above 40 or 50 degrees Celsius. So in the area between Devon and Rocky Mountains, you can get to 40 or 50 degrees Celsius, in some cases around a kilometer or half depth. So
Okay.
very promising uses. Anything that you can think of that you need to heat, you can heat with a geothermal source. There's economy of scale about it. You probably don't want to drill a 1,500 meter well to heat one single family home, but that 1,500 meter well could heat, 100 single family home residential development kind of thing. And so maybe on the individual homeowner side, maybe these guys are more interested in looking at Geo Exchange systems for their small use. But if you're a land developer, or if you're running a farm co-op where you might have, an acre or two of greenhouses, or a big cow barn, or whatever that you need to heat, or, place where you're keeping your hay for the winter that needs to be kept dry. I don't know. I'm not a farmer. I've lived on a farm, but not on the farming side of things. So anything that you can think of that you need to heat, you can heat with a geothermal resource. And in Alberta, in many cases, you can do it more cheaply than you can with gas.
Okay.
Yeah.
Well, that's saying something.
Yeah.
We are going to slowly get into the farming part of this shortly. Just one question I have about Orphan Wells, because obviously there was a Supreme Court decision recently. Basically, what the Supreme Court ruled was, if you're a company, it doesn't matter if you've gone bankrupt, you have to remediate these sites where you had oil and gas wells before you pay back your creditors, which obviously for a lot of farmers is a big deal because we have, hundreds or thousands of orphan gas and oil wells just kind of sitting around. Geothermal quite often has been held up as a solution to these orphan wells. Like, okay, if we can't use it for oil and gas, why don't we just switch them over to geothermal? And I'm just curious, because I have your expertise in front of me right now. Is this legit? Is this really a good use of geothermal?
Well, it is certainly a multi-billion-dollar question. It's probably a multi-hundred-billion-dollar question, frankly. If you look at, it depends on how you frame the question. If you frame it as a liability issue, certainly tens, if not hundreds of billions of dollars in liability out there. If you frame it as the amount of infrastructure that Albertans and Canadians have invested in the Albertan hydrocarbon industry, it's really $1 trillion question. The answer to which nobody knows. So I don't have the specific answer to the question, but I do think that it's important to frame the question properly.
Okay.
So you mentioned Orphan Wells. An orphan well is a well that some company, just ghosted on the responsibility to deal with it. And so now it's on the province's books. The number of these wells in comparison to the total number of wells that are in Alberta is actually vanishingly small.
Okay.
And it changes a lot. It can be, in 1 month, it might be a couple hundred wells. In a couple months, it might be 5 figures, 10,000, 20,000 like this. It's not that there are hundreds of thousands of orphan wells out there that can be converted into geothermal power. Mm-hmm. There are hundreds of thousands of wells that will go through an end-of-life cycle and assessment for all of these companies. But from a government perspective, that's not yet their problem.
I see.
The Alberta government is not well incentivized to create a mechanism for oil and gas companies to transfer that liability to upstart geothermal operators. They see that as a recipe as having a lot more orphan wells on their books than they need to in the future. I think it's important to bear that in mind as some of what are the political dynamics behind using these wells are. Mm-hmm. And I think that's wise of the Alberta government. Not to just let people who have the resources and originally took on the responsibility for these wells just to pass it off on some people for something that's really unproven. So as far as proving it is concerned, the reason why these wells are being shut in is because they're either not functioning properly anymore or they've reached the end of their useful life cycle. So the question immediately becomes, can they now start circulating tens of kilograms a second of water for geothermal use? No.
Okay.
In most cases, no. Some oil wells, yes. Gas wells, no, not really. Mm-hmm. So then what we start to do is we start to look at, can we use the well themselves as a downhole heat exchanger? So this gets into like deep Geo Exchange now. I mentioned earlier that Geo Exchange typically stops at the upper 100 meters or so of the earth. But we have, 50,000 wells that are 4,000 meters deep or whatever here. Can we turn these into deep borehole heat exchangers without having to circulate fluid from the reservoir? Can we seal the well, put a coiled loop of something? And so we do a lot of modeling here. In fact, I was just reviewing a manuscript that one of our postdocs, Alex Hugh, he's been doing very advanced modeling of doing this. And this is the kind of thing that would work very well in an agricultural setting for heating a greenhouse, because you can't produce a very high temperature of heat, but you can produce a lot of it. So if you need to run a greenhouse or an agricultural drying operation, or if you have some sort of aquaponics going on and you need 35 or 40 degrees constantly, reliably, boom. Most wells in Alberta are suitable for retrofitting for those purposes.
Interesting.
Yeah, most let's say most wells deeper than 2,000 meters, which is hundreds of thousands of wells, are suitable for that type of retrofitting. And so now we start to look
just
at the
gas well? Or sorry, I didn't mean to interrupt, but I know earlier you mentioned like gas wells, not so much. Oil wells, okay. What's the issue there? Or in this case, doesn't matter?
No, okay, yeah. So I did mention, I don't know if I mentioned it here, or if I mentioned it
could have been a previous conversation
on the phone with you the other day. Yeah, oil wells tend to produce a lot more water than gas wells. If you're looking for like an aquifer, the oil wells are typically more in water bearing strata than the gas wells.
Got it. Okay.
But because this sealing the well up and using it as a deep source heat exchanger doesn't involve circulating any fluid from the reservoir, it doesn't matter. You can start to use the deeper wells. So then the question becomes, how much heat do you need to produce? And then can you engineer the system? And then how much does that cost? Our models show that if you are able to, and we've done a little bit of financially modelized, if you have a 3,000 meter well, it should cost around this much to create this system.
Okay.
And if you have one of these on your property, it is cheaper to heat whatever you want to heat by retrofitting that well than it is to run your gas burner right now.
Really?
Yeah. Yeah. It'll cost you more money up front, but you'll pay it back. The payout period is pretty quick, and you will save a lot of money in the long run.
Interesting.
FYI.
One thing you said in that previous conversation, and feel free to correct me if I'm misquoting, but you told me that geothermal could really set off like an agricultural revolution here in Alberta. Do you stand by those words? And if you do, what did you mean by that?
Yeah, I'll stand by those words. I've been saying it loudly for years. So there's a lot of this mid-grade geothermal heat here. We made a histogram. A histogram is a chart of frequencies of scores, bar graph, column graph. We made one a few years ago in the context of a study we did with Alberta Innovates that showed the distribution of geothermal pools in Alberta by temperature. And so in Western Alberta, in the counties between Grand Prairie and Clearwater County, so between basically Sexsmith, Alberta and Caroline, Alberta, we identified maybe 50 geothermal pools that are above 120 degrees Celsius. We identified hundreds of geothermal pools that are between 60 and 90 degrees centigrade. And that is like really an ideal temperature for running an agricultural operation. I see as a consumer in Alberta who's, like I mentioned, I've lived in many places, including Florida, which is an agricultural hotbed. And the cost of food in Florida compared to the cost of food in Alberta is astounding.
Okay.
And even to take that a step further, the cost of food in Whitehorse, Yukon, compared to the cost of food in Edmonton, Alberta, is astounding.
Mm-hmm.
You pay twice as much for a salad.
Right.
I'm a vegetarian, so
okay.
Farmers out there, I love your salads. And I go to Planet Organic and I pay $9 for an organic cucumber. For one organic cucumber, I'm paying $9. Why? I don't understand that. The cucumber is like 75% water. But the sunlight costs some money, and the heat that it's grown in costs some money. Yep. And so, but we have two of those things. Mm-hmm. We've got the land, we've got the heat. Why can't we produce food locally?
Mm-hmm. Mm-hmm.
Why do we need to import food from Argentina and California and Israel and Holland? I mean, we import we import geothermal greenhouse-grown cucumbers from Holland to Canada, where we could just grow our own geothermal greenhouses.
Right.
And so this is how a revolution might be a bit bold of a word, but there's definitely a market here. We can supply local Canadian chains, Save-On, et cetera, with local Canadian produce that's grown right here. That is a much larger sort of logistical issue than just growing the food in the greenhouse, obviously. But I think it exemplifies a forward-thinking mentality and a comprehensive type integrated mentality as to how to solve problems. I mean, climate reports say that people will move to the north and they will move inland. This is also my paranoid delusion, but it's not only my paranoid delusion.
Right.
Yeah. Just because I'm paranoid doesn't mean they're not following me. No, I mean, the climate is changing. Sources of food are changing. California has sucked many of their aquifers dry. They do experience drought. We are not very food resilient as people living in Canada, as people living in the north, Not all of us can go grab our shotgun and go bag a moose for the winter, And then we also look at sort of more remote areas. We deal with some indigenous communities where food security is an issue, but then also the quality of the food that they're able to get is an issue. And there are communities that suffer from heart disease and diabetes and stuff that can be addressed with proper diet. And we are in a position where we can use geothermal resources to get food to people, where we can hook up a camp, wherever, with produce grown on site so they can have some, proper diet. And companies that see that this is a good investment also, Suncor knows that it's a good idea to feed their workers a healthy diet if they want them to do good work. So it seems like a winning proposition all around for me. And it also seems like an innovative way to use a low-grade geothermal resource in such a way that it also becomes an export technology for Canada. So that's what I mean by a revolution. Like, we could use this renewable resource that we have here in Canada to really fundamentally change our cost of living, at the cash register for the average consumer here. And then also for Canadian farmers,
Oh, it definitely sounds win-win.
Yeah. So I don't know what
they want to buy local. Obviously, farmers want to stay in business. So it sounds good to me.
I don't know what I'm missing. I must be missing something.
Okay, maybe we'll get to that in the interview.
Yeah.
You've mentioned one major application for this in agriculture, greenhouses. Like, that seems to be the most obvious one.
Yeah.
Have you come across other examples?
I mean, we typically talk about greenhouses, and that can be anything from, really easy type greenhouses like tomatoes and leafy vegetables and stuff like that, to in Holland, again, to use this example, they're growing pineapples and avocados.
Wow.
In geothermal greenhouses. I think that there is, especially as, I don't know what the limits are. I do know what some of the limits are as far as greenhouses are concerned, which is that they don't only require heat, they also require lights. And so until we can come up with a geothermal solution where we can integrate the power and the heat production, or we're in an area where we can integrate the power and heat the production, people are going to go with what they know, with gas. We do see, however, like, for example, on Wellhead, we're partnered with a company in central Alberta right now, Razor Energy, where they have an oil field that's producing a lot of hot water. And every single wellhead here, we could, with existing technology, produce 75 to 100 kilowatts of electricity.
Oh, wow.
And, so these growing containers is all the rage in agriculture these days, of vertical farming and shipping container type farming. One of these full-size shipping container grow ops, and you can grow anything in these things as far as I'm concerned, they require 20 to 30 kilowatts of power. So conceivably, you could run 3 to 5 full-size shipping container agriculture, grow boxes off of one wellhead.
Wow.
So, that all falls under agriculture for me. I really don't know how to distinguish too much. If you go up the temperature scale, you can start to talk about drying in an agricultural setting. So if you're drying grains, drying fruits, whatever you got. If you really start going up to the temperature scale, you can talk about drying timber, which is a big business, which requires a lot of heat and energy. Alberta specifically, aquaculture, maintaining fish ponds through the winter, or keeping a stable environment, any type of hydroponic operation.
Okay.
I don't know. You tell me.
Yeah, I'm wondering,
keeping your cows warm in the winter.
Well, yeah, I was thinking that too, because I know a lot of cattle ranchers. One of the biggest issues right now in the winter, especially when it's freaking minus 40 out, is getting water to cattle, because pipes start freezing, dugouts are freezing.
100%.
So I'm wondering, maybe geothermal is a place there. Grain production. Yeah, I don't know for wheat and barley. I don't know if maybe geothermal wouldn't be the right fit for them. I like the drying part, you brought up for sure, but actually seeding in the winter, I don't know if that would have an application.
I don't know.
Yeah.
I don't know. It is possible to, excavate an acre down, 5-10 meters of topsoil, excavate it, lay a geothermal heating network in there, and fill it back in.
Okay.
I don't know if that's a good idea.
No,
it is possible to do that. I'm not advocating that right now.
Right.
It is possible to do that if you think it's a good idea.
And we'll find out in 10, 20 years.
Maybe. Yeah.
I think we've probably established through this conversation that geothermal is pretty awesome. And you just said this actually a few minutes ago, you don't get it, why there hasn't been a big uptake, or but I'm sure there must be something that's in the way right now. There must be some sort of barriers that just makes it hard for us to go to practically no geothermal right now in Alberta, to that revolution you're referring to earlier.
Yeah. Well, I think the lighting issue with greenhouses is actually significant, because we can give you all the heat that you need, but it's still dark, 18 hours a day here in the wintertime. So what is, you need heat and light to make things grow.
True, yeah.
So if we can find a way to do this power and heat cogeneration for that particular purpose, I think we're off to a good start. And we were working on technology here that would allow us to produce electricity from a lower temperature source, which we haven't talked about much. But and so hopefully, I think within the next half decade or so, we will be able to go to a place, drill a 2.5 kilometer well, and produce enough water to get the heat and the electricity that you need to run a couple hectares, or not hectares, I'm sorry, a couple of acres of greenhouses. I believe that we will be able to do that within the next 5 years.
Okay.
Until then, the heat is there. The electricity is only there once you get up above 100, 120 degrees. Or you go to one of these wellheads where they're already producing a lot of electricity and use your boxes there. So that is an issue. There are some technological challenges that need to be overcome. The other issue that we face in Alberta is that there are some regulatory hurdles. And by that, I mean that there is a lack of regulation for doing this. So it's not illegal to do a geothermal project, but it's also not legal.
Yeah, you're going to have to explain that to me, because I still don't quite get that.
Yeah, there's no legislation on the books that regulates it. So, if you go to apply to, do a geothermal project somewhere, there's nobody to apply to. There's no office set up to handle that. There are no guidelines with which to evaluate your application.
So weird. Okay.
Well, it's it's not that weird. Why would, there's no geothermal regulations in Alabama.
I just figured
I never thought about using it. There are geothermal resources in Alabama that just never thought about using it.
I feel like it's not that new, and I'd expect the regulations and laws to catch up by now, but I guess my expectations are too high.
Yeah, I should probably caveat that comment also and say I don't know for a fact that there are no geothermal regulations in Alabama.
We have a lot of listeners in Alabama, just so you know, so you might be, your name may be
I don't want to be given a bad name in Alabama. All right. So I don't understand. It's a complicated issue. I don't want to, point fingers at the Alberta government. It has been slow in developing, even basic definitions, like what is a geothermal system? What is the difference between a geothermal system and a Geo Exchange system? This is not a straightforward question to answer. Okay. It requires some leadership. It does require, I think, somebody saying, maybe the process is a little over democratized. I don't know. It has been taking a while. They are still discussing definitions like this, and then the question becomes: how does it get regulated? Is it a mineral right? Mm-hmm. Is it a water resource? Is it regulated the same way that we regulate hydrocarbon resources? Is the government entitled to a royalty structure, or did the government just get their tax on get their end on a tax basis, or what type of financial incentives can be put in place to help, the companies without crushing them. You know what I mean? And so these are complicated issues. I think the government has a lot of people from the commercialization end yapping in their ear about it should be like this or it should be like that, or trying to give them advice.
Okay.
And, that's taking a lion out to the shepherd's flock and asking him what he wants for dinner. If that's a good analogy, I don't know. I mean, it's not an unbiased or completely credible,
of course,
recommendations. So, and then we come at it from the academic perspective, and we have done some consulting with the government on this as far as case study reviews and jurisdictional reviews and such. But, we're not the fastest operators in the world either. At the university, yeah. So there are a couple projects moving forward in Alberta on a pilot basis or a demonstration basis that I hope will be successful and that will, help the government start to build meaningful fences around what it means to do a geothermal project in Alberta. But that is, for the time being, another significant holdup. It also prevents developers from being able to take a project to the bank. You can get your power purchase agreement, you can have your end use, and you can have all your finances worked out, but a bank is not going to sponsor a geothermal project in Alberta until there's a legislation on the books that regulates it.
So say there was a farmer who wants to operate in this very gray legal zone, because technically they could probably still get some sort of geothermal operation going if it's not illegal, I'm assuming, or you go straight up the middle. But anyways, but we'll pretend in Derek's make-believe world that they can do this. Basically, if you want to get this greenhouse going, what kind of costs would you be facing?
Oh, it really depends on what you want to do. So if there's a well on your property that is not producing right now, or that you have access to, and you want to try to do this sealed well type thing, you're looking at, it depends on the depth of the well. So there's a fixed cost of retrofitting the well. You need to seal up the existing production zones, which is called putting a packer down there.
Okay.
Depending on who you hire to do it and how long it takes them to do it, that can cost, in the 5 figures. So, yeah, $30,000 to $50,000 or $60,000, depending on the depth, the type of packer, because you got to mobilize the crew and they got to go out there, and there's a big rig, and it's a bit of an ordeal.
Okay.
And then there's a per meter cost of putting in a new tube and annulus, which seals up the well, and that's what you circulate your propylene glycol for through to get the heat out. And that's on a per meter basis. So the longer your well, the more you're going to spend there, but then the more your heat you're going to get out. All told, for a 3,500 meter well, I think we estimated in 2016 it would cost maybe $300K altogether with materials, labor, putting in the packer. And then you have enough heat to run a substantial greenhouse operation. Okay. So there's an economy of scale here. It does not make sense to do this if you are, an individual, let's say a gardener, as opposed to a farmer.
Right.
More likely this is something that a community would come together and say, yeah, we want to do this and operate a community. A co-op of farmers or a municipal district themselves would come together and say, yeah, we have 7 wells over here and we want to repurpose 3 of them for this particular purpose. And so that it needs to be of a specific size in order for it to justify the cost. But once you hit that size, your economics look good compared to gas.
Okay. So there are a few veggie co-ops out there. I can think of Innisfail Growers as an example. There's YYC Growers in Calgary.
Well, the heat can be distributed over quite a distance. So if if you're in an area, if you're in an agricultural area of Alberta, and there's Farmer Bob over here and Farmer Bill, 7 kilometers over there, and their cousins Bert and Ernie down here in this corner. And you have kind of a centralized area, you can truck that heat out, 10 kilometers and really in any one direction. So it doesn't all have to be now we've got this geothermal system and here's our big greenhouse. It's we have a district heating network for agricultural purposes around this area. So I really think the key here to getting this whole thing off the ground is creative thinking. The heat is there, the resource is there. It's not terribly expensive to access it in Alberta. The question is, what are the ways that we can use it? How can we, I don't want to use the word monetize it, but how can we get it to where it needs to go? Where does it need to go? How do we get it there?
Right.
And I think that really requires local ingenuity and know-how. And I think that we have a lot of that here in Alberta.
I agree.
Yeah.
And in the case of those co-ops I just mentioned, say one of them actually does want to pursue geothermal for their operations? Like, any recommended first steps for them, or should they just wait for the government to get its act together? And
they should send me an email and tell me where they want to do their. I hate to plug myself here, but you threw me a softball. I would recommend that they contact us here at the University of Alberta. Okay. We will look to see if there are any wells in their area, and we'll be able to tell them within a day, whether or not there are some wells in the area that might be suitable for doing this. And if there are, we can. We are not commercial geothermal energy developers, but we can certainly guide people in the right direction. And when it comes time to actually start building the project, we can also point it to some commercial vendors that can really get that done.
Question?
I have no financial stake in any of those commercial vendors. Just also full disclosure, I work for you.
Like, they don't have to name the greenhouse after you or anything like that?
They do not have to name the greenhouse after me, no.
The future of geothermal in Alberta, are you optimistic, pessimistic, too soon to say?
I'm still here, even though it's minus 40 out right now. So I guess my general outlook is optimistic. There's certainly been a generous investment by both the provincial and the federal governments in geothermal energy research in Alberta, dating back 10 to 15 years, but in the last 18 months, the federal government has invested a lot of money in geothermal energy development in general, and specifically in Alberta. And the Alberta provincial government is also investing a lot of money in geothermal, on their term. I mean, we're not talking about hundreds of millions of dollars, but in what's available for academic funding and foundational and applied research to try to make sure a non-existent industry knows what it's doing when it starts to exist. They appear to be very much on board. So I'm fairly optimistic. I expect to see geothermal power installed in Alberta within the next couple of years. Yeah.
Okay. Well, looking forward to
I'm talking geothermal electrical power installed in Alberta in the next couple of years. So we're going to get it done. Rural Roots to Climate Solutions is a central Alberta-based project empowering rural Albertans with climate solutions. Along with producing this podcast, Rural Roots runs workshops and farm field days. For more information about the project, visit the website at www.rr2cs.ca. We'd like to thank the Alberta Real Estate Foundation for providing financial support for the podcast, and the Advisory Committee of Rural Roots to Climate Solutions for providing Derek with much needed and much appreciated support. Members of the Advisory Committee are Brenda Barrett, Dana Penrice, Mark Fox, and Kimberly Cornish. Today's episode was recorded at the University of Alberta in Edmonton. Happy farming wherever you are in Alberta, and remember, what's good for the farm is usually good for the climate.